Oh, my friends, my very, very good friends. When you think you see something that there's no way in the world you could ever explain, such as that. I've been looking at this physics for a year. I got this from Rod's nephew, Dylan. And he just went out and took a picture with his new phone of, looks like the moon, and all of these dipoles show up and all these magnetic fields. And I questioned, I said, how the hell did you get this? And he sent me the settings and so forth and the kind of phone he's got and everything. And I sort of, I mean, what do you say about this? The only thing that I really could get my hands around was that everything is still, because I've said everything is a dipole. And the only time you have magnetism is a dipole. It has to have polarities, which creates fields, which creates all of these little black and white spots. And see these down here? And all of these, and then there was these things on top of the moon, and I'm saying, what the heck is this? How could these be on top of the moon, between us and looking at the moon? Because as far as I'm concerned, these are probably stars. Now this is probably a planet, and the same thing here. That, this looks like a pyramid in space. I have no idea, to be perfectly honest, absolutely none. But so I've been looking at this for a year. I've mentioned this a few times, and I just said I can't talk about it because I have nothing to talk about. Well, now I do. Woo, wait to see this. All right, this is a paper about, this is right out from 2022, about magnetic anomalies over permanently shadowed craters near the lunar south pole, mapping and implications. Now, I don't know where Dylan got those pictures from, but I'm going to show you because there's an impact zone. Exactly what they're also talking about is that the moon has a tail just like a comet, and that comet's tail changes as we hit denser space. I've been saying this for a long time. Now here's what they're where is it? This is, they're showing these impact zones, well, these magnetic anomaly zones. Now, I'd love to see them matched up against Dylan's stuff, or have somebody do something and look at it. But anyway, let's go a little deeper, because I want to talk about this sodium vapor field around the sun, around the moon, which our vacuum of space is nowhere near a vacuum. It's not completely saturated as a solid mass, no, but it is exactly as Fermilab says. It is a writhing, seething foam, quantum foam, which quantum means magnetic particles. That's what quantum is magnetic particles. So it's a quantum foam, which it is. The sun is emitting particles everywhere. The solar wind, and now they're talking about raw sodium. And I can understand that. Like I say, sodium would be ripped, its electrons would be ripped away from it possibly in this, expulsion event from the sun. And the sun is nothing more than being ripped through the arm of the Milky Way and ripping through all of its particles that it has to get through. So that's why the sun is being ripped apart, and we're having to pass through that stuff. All right, let's see if we can get anything more out of this. They are showing these zones of magnetism. Now, this is discussion and conclusion. It says moderate magnetic anomalies are present directly over at least 2 permanently shadowed craters near the lunar south pole. Let's just see if we can find that. Near the lunar south pole. All right, so I don't really see anything that I could attribute to the south pole having 2 areas. I don't know if this is a south pole or not, but it could be. This is dark, this is brighter, but this blue glow indicates a higher frequency of energy. Now, why would there be a higher frequency here than here? See this how yellowish looking that is? Yellow is not as energetic as blue. Why would the blue be more energetic? Is it going this way? And this is being pushed back, and so it doesn't have the energy that has being trailed behind it? And is that why this this field is going here, and this, because we're also spinning, and that might be affecting this. I have no idea, but these are all magnetic fields. These are magnetic fields. That I'm 100% certain of. And these are all infecting and affecting each other's magnetic fields. And this entire, the whole universe is completely saturated with particles. And that has a huge implication on the Hubble Space Telescope and Einstein's theory of the vacuum of space and how all the particles go, there's nothing out there, you know, and also we can speed up and slow down light. There's a big, big thing we have to do here. Now, can I create something like that? Well, I can with my extremely destroyed piece of magnetic tape. I am going to show you something here that is going to be almost, well, it's going to have some similarities, let me put it that way. And again, I have to account for every interaction. So when I see something like that from Dylan, I just freaked out. But here's the really crazy thing, is Dylan is sending me stuff that is above. So it's like, as above, so below. Well, so below, as above. Rod started it out with the so below. This is dipoles. No question whatsoever, these are dipoles. And I have another one that shows a dipole that you won't believe, and that's the one I'm going to replicate. Well, I have it right here. Hold on. And then I'm going to show you what Rod sent me, because he sent me the little ones. Oops, wrong stuff. Hold on. Hold on, take it easy, we're going to get there. Here it is. Now, let's see what this is. No, that's the same one. Hold on. Alright, that's the first one he sent me. That just blew me away. And I said, you got to see what else you can get. And then he sent me that other stuff, and that blew me away just as much. But look at the intensity of this dipole. I don't know what that is. I'm going to go with Venus probably, because the glowier the glow, the hotter the hot. Just all it is. The pushier you push, the more you rub, the more heat you get. Venus spins backwards. Everybody else spins this way. Right-hand rule. Venus is going that way. It's going through the same particles we're going through. We're like rolling over the particles. Venus is going backwards against them. That's why Venus is so increasing. It's like 800 degrees or something. They expected it to be about our temperature because it's in the same sort of regions and so forth as we are. It's about the same size. They expected the same scrub or the same whatever, same interactions, and hell no. And Velikovsky predicted that in 1950. And by the time they had Mariner and all these things going out into space, they proved he was right. Well, they had already destroyed his life. And he's never come back from that. And 99% of the human race will never know his name, or at least certainly doesn't know it now. I'm hoping that that will change, and I am certainly working to that end. Now, can I show you this? Well, I think I can. And how can I do it? Well, thank you for asking. Right there is a bunch of little magnetic beads, which are nothing more than little stars. They're dipoles. And there's one big jobber, like we're looking at there. There's a Venus and then a whole bunch of stars. So how can I prove that? Well, let's see what I can do. All right, listen to this now. This is by, I'm going to show you the guy, and these are these strange pockets of magnetism. What are they doing on the surface of the moon? And I think I've already shown you the pictures that we took showing that they are there, and that solves my issue. And this is guy, I believe this is Brandon Spector himself making this video, and he's a senior writer for livescience.com. And I thought this was quite well done. Now, I'm going to let this play it again. You know, Fair Use Act. I'm not trying to steal it. I just want to play off of his information, my research. Here goes.
When a comet soars across the sky, twin trails of gas and dust streak behind it. Now, a new study suggests that the moon may have a similar tail, but it's only visible once a month when Earth passes directly through it.
You hear that? I've been talking about the quantum particles and all the dust and all the gases that are in space that have been overlooked forever. That's what we're scrubbing through. And he's going to make an extremely good presentation of why we should make a point of looking at that. I mean, I'm not sure that's his point, but it will be mine.
In the 1990s, astronomers noticed that the moon has a tail. It isn't visible to the naked eye, but using a special telescope they were able to see the faint orange glow of sodium streaking off of the moon. This sodium tail comes from lunar soil that gets blasted into space when asteroids hit the moon.
Lunar soil. That's an interesting term. Now, sodium, as somebody that's into chemistry would understand, is on the far end of the periodic table, and it is basically stripped of electrons, which is what you would expect to be blown off the sun. It'd be just ripped out of its, all the electrons be ripped off it. So that's why they're seeing sodium, possibly. I'm just throwing that out there, but that's how I would account for the sodium, because it's a byproduct of just atomic ripping.
And it's only visible from Earth once a month during the new moon, when the moon sits between Earth and the sun. When these three bodies are aligned, photons from the sun push that airborne sodium hundreds of thousands of miles away from the moon. Earth's gravity then pinches that sodium tail into a long...
All right, here's what we're going to... I'm sorry to interrupt you, my friend, but I'm just going to make a point. The moon gets in front of us, and the particles from the moon that are being ripped off the moon, now apparently they might be ripped off the sun as well, I don't know, but I believe they're just being ripped off the moon because of impacts with the particles that the sun is forcing against it, just like they force against us. We have a little more substance to keep it away, our magnetic field and so forth, but because of our magnetic field, it's taken these charged particles, and because they are on this end of the spectrum, they are highly charged. NaCl is a totally charged particle. Na, if you can separate it from the Cl, you've got a very, very polar particle, which means it's going to be highly affected by magnetism, which is gravity, and that is Earth. So it pulls those particles in and makes a trail behind the Earth, and that's how they're claiming we can see this. But my point is being that we are being ripped through these particles. We never know how many particles are going to be coming at us, because we don't know how many are coming at the sun and the moon. That's the ones that get stripped off of that, well, mostly the sun. But that's what we have to go through, is those particles. And some days it's a lot of interaction with the sun, and some days it's not. Space is not a blank, homogeneous nothing of zeroness. It's not a vacuum whatsoever. Obviously, if we're scrubbing through sodium, I mean, it's insane to keep going on with this thinking that there is nothing in space.
Beam that wraps around our planet and shoots out the other side. That beam is about 50 times too dim for humans to see with the naked eye, but when astronomers look at it with the right telescopes, they see a fuzzy orange spot about 5 times wider than the full moon. After a few days, it vanishes. That fuzzy sodium spot always appears at the same time each month, but strangely, its brightness is constantly changing.
You see that? Strangely, its brightness is constantly changing. One month it might be bright, the next month it might not be. It depends on what we're running into, or it is running into, and the sun is running into.
In a new study published this month in the journal JGR Planets, astronomers tried to figure out why. After looking at 14 years worth of lunar photos, they figured out that the spot tends to appear brighter when more random meteors are sighted over Earth.
All right, more random meteors are sighted over Earth. We're going through a dense region in space. Basically, that's as simple as that. And when you have all these little meteorites coming down on us, they're dragging a whole bunch of extra particles with it. I mean, I don't know how much easier it can be.
What's the connection? More meteors over Earth means more asteroids slamming into the surface of the moon, which doesn't have an atmosphere to protect it like our planet does. According to the researchers, these random meteors tend to be larger, faster, and more powerful than the broken up rocks that are parts of the annual meteor showers that we see, like the Leonids in November. Bigger meteors mean bigger impacts on the moon, which means a bigger cloud of sodium flying into space and eventually passing over Earth. And so, scientists on Earth see a brighter spot when our planet...
Why would the asteroid specifically make more sodium? I'd like to have an explanation of that. I can understand why the sun would be tearing molecules apart to where they just had a sodium core, because basically that's all it is. When you're way on that left side of the periodic chart, you don't have any extra electrons, basically. And these have a lot of extra electrons. I suppose you can think of it that way. And I would expect you would have less electrons as something was torn off the sun. Not as something was just impacted, you're just going to have all the debris that's on the moon in a cloud. It's not going to be sodium. So these explanations are always so quick and simple. Let's just look at it again. Let's see what he has to say one more time.
Meteor showers that we see, like the Leonids in November. Bigger meteors mean bigger impacts on the moon, which means a bigger cloud of sodium flying into space and eventually passing over Earth.
Why sodium?
So, scientists on Earth see a brighter spot when our planet focuses that cloud into a beam that passes around our planet. The moon's tail and the beam it creates are both harmless to our planet, which has a strong atmosphere to protect it from those pesky particles. So the next time a new moon rises, take a minute to thank our friend in the sky for sprinkling us with a little cosmic pixie dust.
Well, we're going through so much cosmic pixie dust. Fermilab calls it the quantum foam, and that is what we're scrubbing through. Now, we were just talking about the particles that are in space, the sodium. And there's a specific particle, NaOH. Let's talk about that. You know, I found it extremely interesting that they were talking about sodium. And why would there be sodium? Well, sodium hydroxide is NaOH. Na is the sodium, O is oxygen, H is hydrogen. And it is an extremely aggressive molecule, and it says at room temperature it's a white crystalline odorless solid, absorbs the moisture from the air. It is a manufactured substance. Well, in space it can be manufactured by pressure and all the other things that cause this interaction. And I believe the sodium is being ripped from the OH, and I'll show you why I can say that. I'll show you in a second. When it's dissolved in water or neutralized with acid, it liberates substantial amounts of heat, which may be sufficient to ignite combustible material. So it's one of these things that's extremely powerful, and I found it interesting that sodium is what they're seeing in space trailing off. Now let's look at another little doodle. Okay, think of it this way: all stars and planets and so forth are on the arms of the Milky Way in our solar system. Why do we see them in specific lines? And why do we see them twisted back like this? The reason is that wherever there's a lot of glowy white material, energetic material, it will create push to shove. That's why we get these dark lines between these white lines. These are trying to push these particles, and they're trying to push back. So eventually they'll get like a demilitarized zone. And you stay away from me, I'll stay away from you. All right, fine. Well, this whole thing is moving through the galaxy, and the arm is twisting back this way. All right? As it twists back, it tightens the center, just like a wrench. And that's getting tightened, and it compresses that material and creates black holes. That's why black holes are created in the center of galaxies. And the more material that flows into the black hole, the more intense the black hole gets, because the more pull it has on everybody else. But these dark regions is what I want you to focus on right now. And you can see this one. It's going right through a bright region. Wow. What if you were right there and all of a sudden concussed with something like here that was on that bright region? Or here coming right into this thing? That wouldn't be a good place to be, because you've got to cut across its path. We're cutting across. They're cutting across, cutting across. How close are we? Where is our impact zone? Are we in the dark region? Are we in the bright region? How close are we to to debris, which is what causes our impact zone, which causes our heat. Literally, that's what's causing the temperatures on the Earth as we scrub through these things. Now, the NaOH was something quite interesting, because I will show you because of what. All right, now, this is the solar system that we are in. Everybody's being ripped through the galaxy, as you saw on the arm. So the heaviest part is it leads, and we are all trying to catch up to the sun. So we trail behind in the particles of the sun that it leaves out of there. That's why sodium, I can understand the sodium now, because it would be ripped away from the O and the H, which is the smaller particles. They're a little smaller. So you have sodium, you got your H is the smallest, and it's everywhere. It's everywhere, everywhere, everywhere. O is another gas, and you find them, a lot of them, the O and H's together. It makes water, and it's a soluble, and sodium is over here. So the sodium is being ripped off of here, and there must be some watery gases somewhere out there. And that's where you normally find sodium, is attached to some water molecules. I would think, maybe not, maybe it's somewhere else. Anyway, we're flowing through it. I am confident that they can see that, because they have spectroscopes and all that business. They can actually see the molecular signature that's given off, and they can tell that it has the frequency of sodium in this case. Now, we're all trailing around like this. Now, don't forget, Venus is trailing, going this way, but it's spinning backwards on its axis. So we're just sort of rolling like down the road. All right, think of it this way. Think about it this way. We're rolling down the road just like that, so no big deal. But what if we're rolling down this road, but the tires are spinning backwards? That's what happened to Venus. That's why it's 800 degrees or so. That was totally missed, and still to miss today. They still don't have any idea. I'm not kidding you. And these are all the particles that are in space that are causing the patterns that I'm going to show you from Dylan, or have shown you. They are just absolutely stunning. But this is the kind of fields you see. You see, these are magnetic fields, and they're all over the place in outer space, because all the particles push to shove each other, and they sort of set up interference patterns that, stay away from me, I'll stay away from you, and that's what happens. And it's just the way it works. So in space, whatever we come into, we're going to bump into. We're going to bump into it. That's why all this stuff is being scrubbed off of here. If we're coming into blank space, we're in good shape, because we're not going to get flooded with particles. If we're coming into a denser space where there's all these meteorites and stuff, they say that's when this all happens. Well, obviously, because that's a denser region of space. We have to get through it. We have to get through it. When we get through it, we may get to a nice place where there's not a lot of stuff. But right now, it doesn't look good. All right, I find this absolutely stunning. Stunning. This is just in March 3rd of 2022. That's just a few days ago. Space vacuum, space in which there is no matter, or in which the pressure is so low that any particles in space do not affect any processes being carried out there. It is a condition well below normal atmospheric pressure and is measured in the units of pressure, the Pascal. Well, it may be a vacuum and less pressure, obviously, because it's not being attracted to the Earth gravitationally, but it is saturated with particles, and they say there's no particles, they just don't affect anything. Like hell they don't. They slow down light, they cause all kinds of quantum foam interactions. Totally, fully understood, and the top people in the world, Fermi Lab, CERN, they have no idea about it. I'm not kidding you, NASA. They just don't even consider it. It's just like it's not there. You can see it. It's not there. It has no effect. Do not affect any processes being carried out there. That's insanity. This is how bad science is. You just saw it. Oh yeah, space is a vacuum. No, it isn't. What gases are found in outer space? You might think space is empty. Outer space should be empty, but scientists say it is not. They know it's not empty. Stars need gas. You got helium and hydrogen all over the place. And really, helium and hydrogen is what's being stripped from the stars. It's not what the stars are made of. It's the particles that are easily stripped because they are these tiniest particles, helium and hydrogen, way down here. They just rip right off of there, go flying out. Now, gases above the planet, intergalactic discoveries. The intergalactic means between galaxies, not even within the galaxies. Like on Earth, rivers transport water from one location to another. A hydrogen river may flow in intergalactic space. Well, it does because the particles that make up space are the same particles that make up light. Where do you think light comes from and goes? I've shown it 1,000,000 times. This is light from a red pulse laser. This is light accelerating. That's not supposed to happen according to modern physics. And light is not supposed to be a dipole, which it is. That's not supposed to be that way. Well, it is, and it makes up the nucleus of all atoms. All atoms have a nucleus, which means the center. The dead center of the atom is its nucleus. And a nucleus is not like one big gigantic ball that is just a big solid ball. No. And they say, well, it's made out of a few protons. No, it isn't. It's every proton is not like a big ball either. Every proton is 1,839 little tiny electrons. And every electron that's a photon. Photons are constructed of 2 electrons. You see the 2 of them here, back to back, those 2 particles, black and white, just like 2 little bar magnets back to back. And that is what fills our space. Everywhere in space, wherever glow is, it will spit out these particles. They're everywhere. So that is what we're crushing through. And they still think it's a vacuum. Absolute insanity. I can't even believe the incompetence of the people that are running the show. It's just stunning. First thing I want to show you is this, which is like particles in space. There's a similar look to it, which is these magnetic fields are all interplayed with each other, and there's some big ones, some little ones. I just have a bunch of little ones all tied together, and then a big round one. But this is the kind of thing we see in space in those, in those pictures that Dylan did, the fields in space. Now, let's talk about this OH situation, NaOH, sodium hydroxide. Well, guess what? These are the 2 primary molecules, the particles that are in space, is O's and H's. And these are surrounding our planet. Now the sodium is torn away and leaving the remnants of the NaOH. As far as I can tell, the sodium, I don't know what's in the sun. But apparently if the sodium is being ripped off the sun, which to me is what's going on there, these OHs somehow were attached at one point, or more than likely. That's my take on it right at the moment. But anyway, this is our scrub zone. This is what's heating everything up, and this is what's causing our problem as we swirl through space, spinning and scrubbing. And that is creating all these magnetic fields. It's just like if you took a motor and looked at the magnetic fields that surround a motor, same sort of things. There's going to be all these kind of fields affecting each other. Now, I have looked at this in ad nauseum. That means a lot. And what did I come out with? A lot of confusion. Now, what was I confused about? Well, first of all, they say the moon doesn't have a magnetic field, and I could agree with that. We're in some kind of a field here, but it's overlapping the moon. In other words, the moon, it doesn't even appear to be hardly interacting at all with this field. That I find kind of interesting. Although I do see the blue and the yellow, which is 2 different parts of the spectrum, it's interfering with something here. Whether the blue is a product of this glowy interference, or whether the blue is a product of pushing forward or pushing this way, or at this point, I'm very confused about that. I, I can see a dark spot here. Why? And I can see something here. If you look, stand off, and you look, you see almost like a roundish area here. Is this? Are these the dipoles of the moon? I don't know. I have no idea at this point. But I could see these over the top of the moon, and boy, that one there sent me right off the cliff. I looked at that and said, this is impossible. How could this be? How could it possibly be? But if they are on the surface of the moon, well, now we're in a different condition here. Because as far as I'm concerned, these are all dipoles. Let me just show you real quick the shots Dylan sent me. I'm just going to run through them. There's only a few here. Let's see what we got here. All right, look at that. Those, as far as I'm concerned, those are all stars. That's the moon. And, you know, it almost looks like he pasted it in here, but it's not. These are so powerful, these phones now. And all these are the background pixelizations inside the phone. This one here, there you go. There's a dipole there if you ever saw one. That's a dipole for sure. And that apparently is the moon, not a dipole. Right, because the moon has no magnetic field. This was just one. This is the first one he sent me, and I saw that and I said, "Get yourself back out there and get some more of these, brother." And he did. I mean, and you could see again. How is the moon affecting these magnetic fields? It doesn't appear to have a whole big effect. You see how they're tunneling down in here, and they're just tunneling right over the top of the moon. And the moon does not appear to affect these things. And look at this, right on top of the moon. This just blew me away. This was the first one he sent me, and that was just... Now look at this one here. White and blue this time. It's inside of the blueness. I don't know. I just don't know anymore. Look at this. These are the Pleiades, I think. And there's the moon is in there, and what the heck is going on here? But they're definitely dipoles, and there's definitely some fields going on. And this was at 10:20, a little later at night. Look at that. Isn't that stunning? So this was 9:40 the same night. So it's at 9:40 at night. Now he's down in New Zealand, so he's down in the southern hemisphere. And this is 10:20, blood moon eclipse, he called it. Now, and I could understand that. If something there is infecting that field, which would, you know, blood moon would indicate like a red moon to me, which would indicate some kind of an interference with its normal output. And I believe that these are the names he put in there, blood moon eclipse. Well, that's just some papers I had written a long time ago. Anyway, this is all I could think of is this has to be like it's moving and twisting and something's pushing off this edge, or I just don't know. But this doesn't have a whole lot of excess activity, and this has a ton of excess activity. And look at this bugger. One little white spot has infected some blackish looking big thing, and it's bigger. Now, that's got to be a planet or something. If all moons don't have magnetic fields, then you don't get this kind of effect. You get this kind of effect where you can see it, but it doesn't seem to affect the other fields. It's very strange. All right, this is troubling as hell. There is just an enormous heat anomaly going on there. 30 degrees Celsius above normal. That's 86 degrees in Fahrenheit above normal. It's a hot spot where it should be absolutely freezing cold. I mean, way below zero. Okay, I don't know how much more serious this can get, because I think it's just about over, to be perfectly honest with you. From what I'm seeing in the environment and what's happening to the poles shifting, and the axis of the Earth is even twisting, and Antarctica, absolute unbelievable record temperatures down there. The turbulence in the atmosphere is unbelievable. Weather patterns are changing. Where it's hot, it's getting cold. Where it's cold, it's getting hot. Where it's wet, it's getting dry. Where it's dry, it's getting wet. It's the shifting patterns because of the expansion of the gases. Everybody's new. Every one of them. CBS, ABC, NBC, whoever this is, Sky News. It's all over the place. We have to do something immediately. And I am trying to get somebody to pay attention to the technology that I think can help. And I don't need a whole lot of intervention here. I just need a few people that are really serious, and I can't find one.